So let's start now. So today I am going to tell you the concept of binary search. Yesterday I told you the concept of linear search. I hope you remember the concept of linear search. Now today there is a binary search. Now what is a binary search? Let's understand this. What is the binary search here? Suppose, but remember that I am going to enter the data in a sorted order. Remember, I am going to enter the data in sorted order. Okay? म्हणजे मी जो डेटा एंटर करणार आहे तो सॉर्टेड ऑर्डरने करणार आहे. हा, रिमेंबर दिस. I am going to enter the data in a sorted order. Okay, remember this. ठीक है. So data is 10. Suppose 20, 30, 40, 50, 60, 70, 80, 90 and 100. Now, if I ask one question here, example, I want to search the value 80. Suppose if I want to search the value 80. Okay, let's take a very basic example. If you have a telephone directory or if you have any book, okay, where you can check in the index. Suppose you want to search the chapter number 8. मग काय केलं तुम्ही? You can check the index की chapter number 8 is available and page number suppose 75. Now, if you open the book is the middle, if you open your book at the middle, you got the page number 50. Suppose, okay. After this, now you know that your book you will get in the second half. Am I right, everybody? जर तुम्ही बुकला मध्ये ओपन केलं, तुम्हाला कळलं की चॅप्टर नंबर 8 हे 75 पेजवर आहे, पण आता पेज नंबर 50 सापडला मला. मी बुक ही जर एखादा बुक आपण अशी मिडल मध्ये ओपन केली तर, if I open the book in the middle, so I'll realize that ki right now the book page number which I want, I will get in the second half here. मग मी काय केलं, मग आपण काय करणार, परत त्या बुकला मध्ये ओपन केलं. So you got the page number 80. Now suppose तुम्हाला जो डेटा पाहिजे तो पेज नंबर 50 आणि 80 च्या मध्ये, मग तुम्ही परत याचे दोन पार्ट मध्ये त्याला ओपन केलं. So finally you got your data. Example, you got your data here. ठीक है? So try to understand, your data is in a sorted order. Suppose I want to search the number, take example 70. I want to search the number 70, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what I am doing, suppose pass 1 equal to 0 plus 9 divided by 2. Pass 1 is equal to 0 plus 9 divided by 2. 0 plus 9 divided by 2. I got the value 4.5. I will assume the 4. This is the mid. याला काय म्हणायचं? Mid म्हणजे काय? Middle value right now. Now I want a number. Yes, middle value, correct. Okay, then I want to search the number 70. Remember, search number काय करायचं आहे? 70. Then like compare your value with the value which is at the index 4th position. Okay, compare your value. So 70 is greater than 50, or I can say 50 is greater than 70. No. Then second scenario, 50 is less than 70. Yes. त्याच्या आधी एक सिनारिओ येईल. एक सेकंड. I need one more scenario. Okay, 50 is equal to 70. No, false. Then 50 is greater than 70. False. 50 is less than 70. True. So then what should I do? Then याला म्हणायचं lower bound. हा होता upper bound. Then what I'm doing, pass 2. In the pass 2, if your number is greater than middle number, then you can say that lower bound is equal to mid plus 1. तर तुम्हाला जो नंबर सर्च करायचा आहे तो मिड पेक्षा ग्रेटर असेल, so lower bound equal to mid plus 1. So shift this lower bound here. Everybody understood this formula? Please tell me. The number which you want to search, if the number is greater than the middle number, then lower bound equal to mid plus 1. Everyone, please tell me. Okay? If the number which you want to search here, if your number is greater than a middle number, then lower bound equal to mid plus 1. Lower bound is equal to mid plus 1. So lower bound is here and upper bound is here. Lower bound is here and upper bound is here. Now, after this, again find out equal to lower bound plus upper bound. Lower bound is 5 plus upper bound is 9. Lower bound plus upper bound. Lower bound plus upper bound divided by 2. Lower bound plus upper bound divided by 2. Now number you got, that is a 7 here. The number which you got, that is a 7 here, right? Compare your value with this number now. So 80 is equal to 70. No, false. Then 80 is greater than 70. Yes. 80 is greater than 70. Yes. Then do one thing. This is called as my mid. This is called as the mid. Okay, then do one thing here. Upper bound is equal to mid minus 1. Upper bound is equal to mid minus 1. Now the new mid is 7. 7 minus 1 manje 6. This is called as upper bound. Upper bound, remember this. This is called as the upper bound. Remember this. आता upper bound काय आला? 6 है. What is upper bound here? 6. So this is upper bound now. Remember this. Okay. This is the upper bound now. Remember this. Once again, find out. Go to the past 3. Go to the past 3 now. Past 3. In the past 3, remove this. Okay, past 3, 5 plus 6 is equal to 5 plus 6 divided by 2. So I got a 5 here. Mid इकडे आला आता बघा. This is the mid right now. Once again, compare your value. 60 is equal to 70. No. Then 60 is greater than 70. No. 60 is less than 70. Yes. Then do one thing. Lower bound is equal to mid plus 1. It means lower bound is equal to mid is what? 5 right now. This is not the mid. This is the mid here. 5 plus 1. Okay, 5 plus 1. So here you can say mid equal to किती बोललो तुम्हाला मी? 5, right? So 5 plus 1 म्हणजे होणार 6. Lower bound is become a 6. Now what happened? Upper bound and lower bound both are at the same place. Upper bound and lower bound both are at the same place. Let's go to the past 4. In the past 4, mid is equal to lower bound plus upper bound divided by 2. म्हणजे काय करणार? Equal to lower bound is what? 6. Upper bound is what? 6 divided by what? 2. Answer is 6. म्हणजे you got the mid at 6 index. So this is my mid right now. हा पण माझा mid पण आता हाच झाला. मी इथे लिहितो. Mid पण हाच झाला. Now compare. Mid is equal to your element. Yes. Mid is equal to your element. Yes, true. Mid ला value किती आहे बघा. One second. Mid ला value किती आहे? This is a mid. Remember everyone. Okay. 70 is equal to 70. Yes. True. Element found. Element found. Now compare how many comparison I have to perform here. First comparison was 50. Second comparison was 80. Third comparison was 60 and fourth comparison. Now look at this. I have to compare. I need to perform the 4 comparison here. Am I right? In this scenario, I have compared my element how many times? 4 times. Tell me. In this scenario, I have compared my element how many times? 4 times. In this scenario, I have compared my element how many times? 4 times, right? Please listen. Okay, but suppose अगर मैंने linear search use किया होता तो कितने comparison करने पड़ते? Can you tell me? अगर linear search use किया होता तो how many comparison I have to perform? Tell me. Okay, so 1, 2, 3, 4, 5, 6, 7. So tell me which is the better approach, linear search or binary search right now? Tell me which is the better approach, linear search or binary search right now? Obviously binary search. That's right. Okay, which search? Binary search. Logic कळलं का सगळ्यांना? हे बघा, डेटा स्ट्रक्चरचा कोणता पण प्रोग्राम मी 3 वेने सांगतो. एकदा जनरल लॉजिक, एकदा अल्गोरिदम आणि एकदा प्रोग्राम. क्लिअर? ओके, त्यामुळे डोंट बी कन्फ्यूज. क्लिअर? डेटा स्ट्रक्चरचा कोणता पण प्रोग्राम मी 3 डिफरंट वेने सांगतो. फर्स्ट लॉजिक, देन अल्गोरिदम अँड देन प्रोग्राम. So right now I told you general discussion की how to implement the binary search. म्हणजे तुम्हाला थोडंफार आयडिया मिळाली असेल. आता आपण अल्गोरिदमने बघूया. ठीक आहे? लेट्स गो टू दी अल्गोरिदम. Okay, note down. It is used for searching the large list. It is used for searching the large list. Searches the element in very few comparison. Searches the element in very few comparisons. Can be used only if the list to be searched is a sorted. Listen, is used for searching the large list. Searches the element in very few comparison. Can be used only if the list to be searched is a sorted. ही line लक्षात ठेवा. If your list is sorted, then only you can use this one. So they have given one example. If you have to search for the name Steve in a telephone directory that is sorted alphabetically. To search the name Steve by using the binary search algorithm, you open the telephone directory at the middle to determine which half contains the name. Open that half at the middle to determine which quarter of the directory contains the name. Repeat this process until the name Steve is not found. Binary search reduces the number of pages to be searched by half each time. म्हणजे प्रत्येक वेळेस तुमची पॉसिबिलिटी ही हाफ होत जाणार. पहिल्यांदा मिडल मध्ये ओपन केलं, मग ते मिडल मधला मिडल ओपन केला, मग परत त्याचा मिडल ओपन केला. सो एव्हरी टाइम यू आर डिवाइडिंग द पॉसिबिलिटी टू हाफ. ओके, consider a list of 9 elements in a sorted array. Suppose this is your list 9, 13, 17, 90 वगैरह वगैरह, right? Now you have to search an element 13 in the given list. म्हणजे तुम्हाला नंबर सर्च करायचा आहे 13 in the given list. Okay, remember this. You have to search the number 13. म्हणजे हा नंबर सर्च करायचा आहे. लक्षात घ्या. आता यांनी काय केलं, काय सांगितलं बघा. Determine the index of the middlemost element in the list. Lower bound plus upper bound divided by 2. 0 plus 8 divided by 2 म्हणजे याला आन्सर आलं 4. 0 plus 8 divided by 2 म्हणजे याचा आन्सर आलं 4. Look at this is the middle element. 0 plus 8 divided by इंडेक्सला डिवाइड केलं. इथपर्यंत कळतंय का? प्लीज रिप्लाय. मिडल एलिमेंट कसा काढला हे कळलं का? प्लीज रिप्लाय. हे महत्वाची स्टेप आहे. Okay, 0 plus 8 divided by 2. Okay, remember this. Okay. Now you got the middle element, that is a 25. 13 is not equal to the middle element. म्हणजे 13 हा याच्या इक्वल नाहीये. 13 is not equal to the middle element. Therefore, again divide the list into two halves. So lower bound plus upper bound. मग upper bound मी काय केला? मिडलच्या एक मायनस करा. म्हणजे मिडल -1 ला upper bound सेट करा. Because your element is less than middle. Your element is less than middle. Therefore, take the upper bound to this position. But suppose if your element is greater than middle, then change the lower bound to middle plus 1. This step is clear? Please reply. If your element is less than the middle, then middle -1 la upper bound set kara. If your element is greater than the middle, then lower bound change to the middle plus 1. This step is clear? Everybody? If your element is less than the middle, then take the upper bound here. But if your element is greater than the middle, then take the lower bound here. Okay, म्हणजे एक तर अप्पर बाउंडला इकडे करा किंवा लोअर बाउंडला पुढे करा. रिमेंबर दिस. नाउ okay, after this, right now upper bound is middle -1. Once again, is 3. 0 plus 3 divided by 2, you got the middle 1. Middle is 1. Now 13 is equal to the middle element found at first index. Element found at first index. Look at this, just two comparison. आता म्हणजे कोइन्सिडेंटली जर तुम्ही जर लिनियर सर्च वापरलं असतं तरी पण दोन कंपॅरिझन झाले असते. Because the element is at second position, but that is just by chance. Okay, but our algorithm is what? Confirm for any type of number, any number. Even तुम्ही 40 जरी म्हटले असते तरी दोनच कंपेअर का? तुम्ही 40 जरी सर्च केला असता तरी पण तुम्हाला दोन कंपॅरिझनच लागले असते. क्लिअर? 2 किंवा 3 मॅक्झिमम. अंडरस्टँड? इफ युअर नंबर इज लेस दॅन, सपोज जर तुम्ही 40 जरी सर्च करायचा असता तरी मॅक्झिमम 2 किंवा 3 कंपॅरिझनच लागले असते. एम आय राईट? जरी तुम्हाला 40 सर्च करायचा असता तरी 2 किंवा 3 कंपॅरिझनच लागले असते. एम आय राईट एव्हरीवन? Write an algorithm to implement a binary search. Let's take an example. Accept the number to be searched. Okay, I need an Excel sheet here once again. Okay, listen. Suppose this is the list here. Okay, this is the list here, and remember this is the algorithm here. Accept the number to be searched. म्हणजे प्रोग्राम लिहायचा आहे. लक्षात घ्या, म्हणजे प्रोग्राम लिहायचा आहे. लिसन केअरफुली. I will write a few steps of the program. Printf. Okay. One suggestion. Listen. Those who are doing a Python, they can try this program with the Python. If you are doing C++, so please try the program with C++. No problem. ठीक आहे? पण ज्यांना सी कम्फर्टेबल आहे त्यांनी आधी सी मध्ये करा. पण वेळ असेल तर नक्कीच पायथन मध्ये किंवा C++ मध्ये करा. बिकॉज ऑफ युअर अकॅडमिक्स, सेकंड इयर अकॅडमिक्स. सम इन कॉम्प्युटर ब्रांच, okay, you have to execute the program using C++. But in IT branch or ENTC branch, you have to execute this program using the C programming. Okay, remember this. Computer branch needs the C++, and IT and ENTC branch requires the C programming. Enter the number to search in array. Okay, scanf %d, %s. Okay, what is the second step? Set lower bound equal to 0. Okay. Integer lower bound is equal to 0. Okay. What is the next step? Upper bound equal to n minus 1. Integer upper bound is equal to n minus 1. Okay. In diagram, lower bound is 0. In diagram, upper bound is here. Okay. Find out the middle, equal to lower bound plus upper bound divided by 2. Okay. Integer middle equal to lower bound plus upper bound divided by 2. It means, okay, 0 plus 9 divided by 2. You will get the answer 4. You will get the answer 4. Okay, remember this. You will get the answer 4 here. Remember this. Okay, listen. 0 plus 9 divided by 2. Okay. Lower bound plus upper bound divided by 2. Okay. Okay. 0 plus 9. So answer is 4. So now if ARR mid is equal to desired element, okay, check the condition. If ARR of mid is equal to search element match होतोय का बघा तर बरं नाही होत असेल तर if element is found, so you can print here element found. नसेल होत तर if the desired element is less than the middle element, okay, compare here. Okay, else if ARR of desired element म्हणजे काय search element if less than the ARR of mid element, then do one thing. जर तुमचा element छोटा आहे middle पेक्षा, so then upper bound is equal to mid minus 1. Check the algorithm. Okay, upper bound equal to mid minus 1. Upper bound equal to mid minus 1. Remember this. Steps कळताय ना मी कशा लिहितोय? मी तुम्हाला काय शिकवतोय? अल्गोरिदम वरनं प्रोग्राम कसा लिहायचा. Clear? I am telling you how to write the program from the algorithm. Clear? Okay. Next step. If desired element, go to next step. Desired element is greater than the mid, then lower bound equal to mid plus 1. Here, else if element is greater than ARR of mid, then what you should write here, lower bound is equal to mid plus 1. Lower bound is equal to mid plus 1. Then आता काय म्हणता येते, lower bound less than का upper bound पेक्षा go to step 4. याचा अर्थ loop. So what is the meaning of this? If your lower bound is less than the upper bound, you need a loop here. You should have the loop here. So ये जो कोड तुमने लिखा है, ये कोड आना चाहिए लूप के अंदर. While जब तक तुम्हारा lower bound ये less than है upper bound से, till the time you have to execute this step. That's it. This is my program here. How simple it is to write the program from the algorithm. Look at this. ये देखो, ये हो गया प्रोग्राम. यहाँ पे मिडल फाइंड आउट करो, मैच होगा तो ठीक है, नहीं तो ये वाला कैलकुलेशन करो. वंस अगेन कैलकुलेट न्यू मिडल, अगेन चेक करो. ये कैलकुलेशन चलता रहेगा जब तक ये कंडीशन ट्रू है. As soon as you got the element, you can break the loop. ये भी एक कंडीशन है यहाँ पे. अगर element मिल गया तो ब्रेक कर दो. समजलं का सगळ्यांना? Everybody understood? Please reply. That's it. This is my program now. Tell me, can you able to write the program on your own using the algorithm? Tell me. हा प्रोग्रामच आहे, फक्त मी रफ लिहिला आहे. Can you able to complete this program by using the algorithm? I will share the algorithm with you. You have to write the program. Okay. Those who want to write in all the 3 languages, you can type, no problem. पहिल्यांदा सी मध्ये करा. ज्यांचं C++ चालू आहे त्यांनी CPP करा नंतर, आणि ज्यांना पायथन येते त्यांनी पायथन मध्ये करा. Yes, Dhanashri, right now it is required. Mate, how to take the element in the sorted order, that we are going to learn in the next topic. Okay. Right now you just enter the element in sorted order, but in the next step we are going to learn the sorting techniques. Okay. So then if you enter data in any pattern or in any order, we can sort that with the help of one algorithm, and then you can apply the binary search algorithm. Clear? Hello everybody, clear? Please reply. So today I will share this algorithm with you. Today I will share this algorithm with you, and by using the algorithm you have to write the program. And after every week I want the topics which is completed here. First theory, then algorithm, then program, and then efficiency. या 4 एरियामध्ये प्रत्येक टॉपिक तुमच्या नोटबुक मध्ये आला पाहिजे. बट फर्स्ट टाइप द प्रोग्राम. I don't want theory, but after every week, whatever I am telling you in the same week, first of all the theory, then algorithm, then program, and then the efficiency of that algorithm or program. Clear? You have to write this in your notebook compulsory after every week. Okay? Okay. ठीक है then. Let's understand the efficiency of the binary search. See, the binary search, with every step, मी पाठवेल तुम्हाला theory. Don't worry, I will share this theory with you. With every step, the search area is reduced to half. In the first case scenario, the element to be searched is found at the middle position. So the number of comparison in this case is 1. In the worst case scenario, the element is not found in the list. Okay, after the first bisection, the search space is reduced by n by 2, where n is the number of element in the original list. After second bisection, the search space is reduced by n by 4. म्हणजे बघा इथे n by 2 होता, इथे n by 4 झाला. Okay, the element, that is what n of square, is ith bisection. The element of the comparison would be n divided by 2 raised to i. 2 raised to i. Remember this. म्हणजे efficiency इथे काय येणार आहे? 2 raised to i. ith bisection म्हणजे number of division you did here. Okay. तर ह्या तुमचं this is called as the efficiency here. First bisection ला n by 2, second ला n by 4, and त्याच्या पुढे n ला काय ना n divided by 2 raised to i. हे तुम्हाला मी पाठवतो theory, don't worry. पण हे कळलं ना तुम्हाला? पहिल्यांदा 10 एलिमेंट होते जे 5 राहिले, 5 चे मग पुढे 3 झाले, 3 चे पुढे 2 राहिले, असं क्लिअर? किंवा सपोज 16 होते, 16 चे 8 झाले, 8 चे 4 झाले, 4 चे 2 झाले, क्लिअर? दॅट्स इट.